Welcome to Spring LIB.
Here the question is Friedel-Crafts alkylation of benzene with 2R, 2-chlorobutane and aluminum chloride affords secondary butyl benzene. A is how many stereogenic centers are present in the product? And second part of the same question is, would you expect the product to exhibit optically activity? Explain with the reference to the mechanism. So we are taking the first part first. A, how many stereogenic centers are present in the product? So how the product is formed first? A is starting with the benzene, and alkyl halide given is CH3, CH, Cl, CH2, CH3, that is secondary butyl chloride, in presence of anhydrous aluminum chloride. Friedel-Crafts reaction is taking place and product is formed. So at the benzene ring, one hydrogen is replaced by CH, CH3, CH2, CH3. This is the product formed, and in this the question is there any stereogenic center in the product? So this carbon is stereogenic center. Stereogenic center is that carbon where the all four valencies are satisfied by different group. So here one is this phenyl group, then methyl group, then hydrogen, and then ethyl group. That is why only one stereogenic center is present in the molecule. So this is the A part. Now come to B part of the same question. Would you expect the product to exhibit optical activity? So for that we have to go to the mechanism of the reaction. First of all, this is 2R, 2-chlorobutane. So this should be one carbon here, and suppose one hydrogen is here, and one part should be below the plane, this methyl group, and one should be above the plane, C2H5 ethyl group, and one should be chlorine. So this is the alkyl halide given, and it is first reacting with the aluminum chloride. Aluminum chloride is electron deficient, so chlorine is giving its electron pair to aluminum. And by that, the product which is formed is carbon below the plane, methyl group, above the plane ethyl group, and hydrogen position should be here, and chlorine position is here, but this is having the positive charge because it is giving its electron pair to aluminum, and aluminum is acquiring negative charge. So this is the complex which is intermediate formed. After that, this chlorine is taking the electron pair and going with the aluminum chloride. So it is losing AlCl4 minus, and carbocation is formed, which is carbon with positive charge. One is below the plane methyl group and one is above the plane ethyl group. So this is the secondary carbocation is formed, which is quite stable as compared to primary one, and it is having sp2 hybridization, and because of that it is having the planar structure. So when it is planar structure, attack of benzene can take place from both the sides. So it can be from this side or it can be from this side. And because of that, two products are formed. So one product can be benzene with one carbon, C2H5 can be here. Suppose methyl group is above the plane here, and below the plane you can imagine hydrogen. This is one of the product, and second product can be benzene C2H5 below the plane methyl group and above the plane hydrogen. So if one is D and other should be L isomer, one is mirror image of the other, and in the product actually we are getting the racemic mixture of these two isomers which are optically active individually, but in the product the chances of formation of these two products D and L is equal and we are getting the racemic mixture, that is DL, 150% D and 50% L isomer, and because of that product is optically inactive.